Hello and welcome to Recyclist. It's October 20th, 2023. I'm your host, Eric Provost, and we are being joined by a very special guest today. Please allow me to welcome to the show right now, Project Director with Martin Construction Resources, Mr. Jacob Nolting. Thank you for coming by the show today, sir.
Yeah, thank you very much for having me, Eric.
And what does Martin Construction Resources do?
So Martin Construction Resources, we do kind of a turnkey approach to anaerobic digester and upgrading projects. So we're an EPC that will take it from a feedstock analysis down to kind of laying out your site, describing the amount of gas that we expect you to produce, and supply a lot of that equipment. Even we'll do the construction. Our sister company, um, Martin Energy Group, will manufacture CHP and partner with a company to manufacture the upgrading equipment stateside using membrane technology. So we take the approach of feedstock to grid entry.
Nice. Well, how many states, what kind of radius do you guys service right now?
We have done a lot of work in the Northeast, specifically New York, Vermont, Connecticut, a lot of those Northeast states. We're also developing heavily in Michigan, Wisconsin, Idaho, um, Washington, and a couple in California. So kind of all over the place.
And what kind of industries are you guys going after right now with anaerobic digestion?
So typically, especially our history has been in the ag space, so mainly dairy digestion, but we are definitely seeing a lot of food waste opportunities, including we've done several co-digestion ag projects with the addition of food waste. Yeah.
Wonderful. So somebody says, "Hey, I've been hearing a lot about renewable natural gas and anaerobic digestion on this amazing Recyclist podcast. I'm interested in moving forward with my site, my company." They reach out to you guys. What is like the process that they can expect to look like?
Yeah, so the first thing we're going to ask is about the feedstock and what materials you have available, whether that's on the backside of a dairy. If it's a dairy, we are going to ask primarily what you're bedding with to be able to determine what kind of systems we may need in place, processing, manure handling facilities, etc., to be able to manage the bedding material. Also, something of significance in the dairy industry is how you are gathering that manure. So if it's flush flume into lagoons, or if you're vac trucking it, those are all things that
Hmm.
um, will alter the consistency of the manure and kind of adjust how we manage it downstream. In some of the other industries, specifically food waste or wastewater, we want to know a lot about your feedstocks. So whether that's fog or in a wastewater treatment plant, if you know what kind of consistencies of things you're seeing come through, to all determine gas production and ultimately what is going to come out of that and how to manage it.
When you said fog there a few seconds ago, what were you in reference to?
Yeah, so that's fat oils and greases.
So after that, in terms of like the actual construction and implementation, what
Yeah,
kind of space are we taking up? What kind of timelines are we looking at? And how do you work through the process?
so after we kind of determine feedstock gas production, how we need to handle those feedstocks,
Hmm.
how we need to manage that going into the digester, um, the the amount or the volume of feedstock that you're going to have coming in every day is, by the retention time in the digester is going to determine the number and the sizing of the digesters. And so that kind of gives us a, a a way to start developing a site plan. Obviously, at dairies, wastewater treatment plants, etc., they typically have to continue to operate um, while you're constructing. So we have to be very mindful of that in the layout and the approach. Um, once we kind of determine a little bit of a layout, obviously we are going to go kind of give early estimates to be able to put in feasibility models for the developer. It is actually always good at this point, even for an EPC or a GC, to have a conversation with the developer about where their financing comes from. So, are you using USDA grants? So that's kind of going to determine some of the timelines and how you go through permitting. Who's managing what pieces of the permitting process? So a lot of times between the developer and the EPC, you try to determine the risk and who wants to carry some of those parts. So when you get kind of through permitting and understanding the feasibility and also um, the where the source of the money is coming from, you can really dive down into the the cost estimating and get to that stage.
Just when it comes to feasibility, in your experience, what are some of kind of the biggest roadblocks that you've seen sites and you've seen companies kind of snag that have halted production, that have halted potential projects? So if anybody's interested in looking at this, what may be some things that they should think about immediately to fix in terms of feasibility?
That's a tough question because it's always um, the cost of the construction project. So um, if we're doing when we're doing upgrading,
Mm-hmm.
you don't have a lot of adjustment in that price. So we can adjust some feedstocks. Maybe we thicken the feedstock, and then we can decrease digester size. Um, in a lot of cases, it can be determined by geotech reporting. I would definitely say that that's something that should be done um, early in the process, as that can heavily dictate differences in the scope.
Okay.
That can find out where you have water table, which can dictate how deep you can dig. It can find bedrock, which also can be difficult to dig in. So, geotech reporting and then electrical availability has been a major issue that we have ran into. And although that's not necessarily feasibility, it does tie into it, but it is definitely a part of project success. We've seen a lot of that alter the not just the cost but the timeline uh, have, by having the power available. And then I think it's the obvious one, but interconnection to gas utility. Generally, they always provide the grid entry unit, but having 4 mile pipelines that cost $5 million can be a huge burden on certain size projects.
Understood. In terms of again the construction, once you guys get in there, what's kind of the average timeline that people can expect from the moment that ground is broken on one of these?
Yeah, so that's a good question, and obviously we're working in as I spoke about, we're working in a lot of colder climate areas, which obviously will shut down a site typically for winter months.
Hmm.
Generally, from something like we'll work as far down into November as we can, and then try to remobilize by as early, but typically in March or April um, on projects like that. We have been successful from shovel in the ground to gas in the pipeline in 12 months, but that's an anomaly. That was a hard pressed deadline. But I would definitely say the anywhere from the 16 to 18 month mark is pretty standard. Um, from contract signing. So that wouldn't be the upfront feasibility where you're developing these site plans and doing development. That would be, you kind of have some permitting in place, you have hard cost estimates, and you're able to go to EPC contract.
Another one of the things, we talk about the cavalcade of benefits when it comes to anaerobic digestion and dealing with odors and just being an efficient and an energy forward way of dealing with manure and biogas and stuff like this. But I wasn't aware, honestly, of like the pathogen destroying capabilities of anaerobic digestion, as potent as it was. And I know, especially with all of the, we're continually seeing more regulations coming out from the EPA and other organizations like that, as we continue to be more climate conscious and much more aware of the things that we're giving off. Is that part of the conversation that you typically have with clients in terms of, hey, we're trying to be, like regulation forward about this stuff? This stuff is probably going to be coming down the, pun intended, but it's going to be coming down the pipeline soon anyway. This may be something you guys want to think about, but also it also helps in these regards.
We have had some of those conversations, but in a lot of this, we're working in the here and now in a lot of these, and trying to get as much um, of the work done and
Mm-hmm.
and the work contracted as we can at this stage. But yeah, we're definitely looking at those opportunities and having some of those conversations with our portfolio type developers that we're working with.
And in terms of like the construction and the science, the technology behind this, are you guys involved in kind of the advancement of those techniques? And if so, what are you guys kind of looking toward the future with?
We primarily use membrane separation technology, which works well in dairy operation. We do have several projects that we're running PSA systems on landfills. But in a lot of the forward thinking aspects is we do have early partners in CO2 liquefaction for equipment that we can provide with that. And then also we have some partners with hydrogen technology to be able to pivot or do things with green biogas as the opportunities come, or as the regulation adjusts in the market.
What are some of the biggest? I know we've kind of touched on this a little bit, but in terms of the process as a whole, outside of feasibility options, what are some of the biggest challenges you guys have faced throughout the course of creating these anaerobic digesters all over the Northeast?
The biggest challenges, like I alluded to, is really the permitting, the utility availability. Being some of these farms are not on a main line, or need a major upgrade to be able to get the amount of power we need. We
Hmm.
have on several projects installed CHPs at the site to be able to help power the rest of the system. The geotech reporting that has been delayed until after the point of contract has yielded major changes in scope and ultimately change orders. The availability of subcontractors, like I said, again, these are sometimes in rural areas, and
Yeah.
you may be an hour and a half, 2 hours from any major place that would have a lot of subcontractors that you can rely on. So to be able to get qualified subs to to perform at the level that these projects require. And then on the topic of subcontractors, is these are mini refineries in a lot of ways. So for the subcontractors, it takes a lot of training to be able to get them to a point where we can just use them over and over on projects. The amount of training, the specialty portions of these projects are difficult.
And in terms of, if people out there might be wondering if they're a big enough operation to consider this, what would kind of be your guiding principles on that, if that's something people are thinking about?
Yeah, certainly. So it's not necessarily the size. I mean, obviously the civil contractors, where where you're you're pushing dirt, you have to have some large machinery and a lot of different pieces. But more so the mechanical, electrical, and plumbing portions, those are not large teams typically. Probably less than 10 in most cases. So these are not huge. Don't have to be huge companies, but it carries a lot of burden from the aspect of we need to have clean safety records. There needs to be all of these administrative practices in order to be able to perform on these sites.
And if there was potentially any operations out there that maybe might be thinking that it's something that wouldn't really impact them, that it's not necessarily something they could think about, what would be some types of operations you think that might not necessarily think about anaerobic digestion as an option but should?
Yeah, absolutely. So anywhere where there is a large majority of food waste, um, even dairies who are smaller, who don't think that they have enough material to have a project just on manure.
Mm-hmm.
I know the difference, that there's a difference in the cost of the D3 and the D5 RINs, but there's also a large amount of difference in the amount of gas produced. And in fact, the biology in the manure, it helps promote the biology in the digester, um, and adds a stability factor for the addition of food waste. So it's co-digestion is a really good potential path because of the stability factor of the bacteria in the manure.
Well, obviously, there's certainly a lot to think about, but certainly a ton of benefits. Obviously, in looking into producing renewable natural gas, looking into anaerobic digestion as an option for your operation, for your dairy operation, for your landfill, wastewater plant, etc. And if anybody out there is interested and would like to contact Martin about potentially getting one of their own, where can they reach you and Martin at, sir?
Yeah, so you can reach either one of the websites, our Martin Construction Resource or martinenergygroup.com. Yeah, that would be a good way to get a hold of us.
Awesome. Well, once again, sir, I want to thank you for dropping by and illuminating us on kind of the process of adding this incredibly valuable asset to your operation. And again, you can visit martinconstructionresource.com, martinenergygroup.com.
Yep.
Awesome. So once again, thank you to Mr. Nolting for showing up, guys, and thank you for tuning in to another episode of Recyclist, brought to you by Diamond Scientific, an industry leader in gas analysis, instrumentation, and solutions. Make sure to visit them online at diamondsci.com. That's diamondsci.com, or call them at 321 223 7500. I've been your host, Eric Provost, and we'll see you back next Friday for another episode of Recyclist. Thank you.